strategies to maximize the advantages that are inherent in biological timekeeping. When teams reside in different time zones, then there's always the opportunity for one team to have an advantage chronobiologically over the other. There's also disadvantages that we need to recognize. And so there's ways in which one can take advantage of chronobiology, and there's ways in which one can minimize the disadvantages. I just want to throw this in because this is the first Monday of daylight savings time. And this is a graph from somebody that David knows, Stan Corrin, at UBC published this some years ago in 1996. And what this illustrates here is the little bar graph. It's kind of a cheating bar graph, but it's cheating in a way to illustrate the point. And the point is, this is the number of accidents, car accidents, and this is the Monday, the first Monday of daylight savings time. So 9% increase in accidents on the road on this day, relative to other Mondays, the Monday before, the Monday after. This is in the fall. There's actually an advantage in the fall. So just a notice of an advisory, travel advisory. Be careful on the roads up there. All right. So this is a slide, a lot of text, but really what it is just a list of 4 studies and the main outcomes of these studies. And what these studies illustrate is how time zones matter, and they matter for actual outcomes. This is also the basis for, it could be the basis for a strategy for gambling that I think over the long term you can beat the house. Just paying attention to what time zones teams are residing in, where they're coming from, what time of day the games are being played at. And some of the outcomes are kind of, they may seem counterintuitive. You might always think that the traveling team, the team that's going across time zones, is at a disadvantage, but it's not always the case. The first paper that came out, this was in 1993, and this was based on analysis of National Football League outcomes. And the summary of the findings was that for night games, the West Coast teams, whether home or away, were at a distinct advantage over the East Coast and the Central teams. Whether home or away, whether the West Coast team was playing in Eastern time zone or in the Western time zone, the West Coast teams were at an advantage in terms of the outcomes. These are actually analyses of what teams won, controlling for other factors like the average, the winning percentage of the various teams. Here's another study that came out shortly after that. This was more of a note, but it was based on a large amount of data from baseball teams. And interesting to note, I know these fellows, and they actually study mice. So they're, in a sense, a lot like me, but they are also interested in sports. So they went back into the archives of baseball, which is notable for having huge numbers of statistics. And they actually found that the West Coast teams were at a disadvantage in games 1 to 2, just games 1 to 2 following East travel. And that's baseball. Football, there was an advantage. Baseball, there was a disadvantage. And there's 2 other studies here that show that football has an advantage and basketball has an advantage. So here we have West Coast teams win more often and by more points per game than East Coast teams. West Coast teams are performing significantly better than is predicted by Las Vegas odds. So they're beating the point spread. And a similar result was found with basketball. Visiting teams are averaging 4 points better when they traveled west to east rather than east to west. And it was sufficient to nullify the home court advantage that would exist otherwise in cases where there wasn't a difference in the time zones from which the teams were coming. So we're looking at large numbers of results here, and we're actually able to look at the final outcome, what teams win. And we're finding that the time zones do matter. So why is that? They actually matter for individual sport outcomes as well. There's plenty of anecdotes, but there are also some bottom line things. For example, most world records are set in the late afternoon and the early evening. So again, why is that? There's a number of reasons, of course, but the 2 that I'm going to focus on, obviously, today are some regulatory systems that control our physiology and our behavior, our cognitive performance. One of the systems is, you can call it a somostat. It's a system in the brain that regulates sleep propensity and our ability to perform cognitively and physically in the face of variations in how long we've been awake. So this is performance being affected by time awake and recent sleep-wake history. The other factor, the other regulatory system, is the circadian clock system. And this is a system that results in performance being affected by time of day. More accurately, it's biological time of day that we're interested in our circadian phase, which is jargon of our field. All right, so I'm going to roll through some slides on sleep and just give you an overview of what we know about the effects of sleep, sleep deprivation, sleep restriction, on physical performance, and on cognitive processes, and also the results of one sleep extension study that's been done. You can feel free to break in with questions anytime. So there's been, in the area of sleep deprivation, sleep restriction, and physical performance, we're going to look at physical performance first. There's been greater than 20 studies done, so somewhere on the order of about 20 to 30 studies, looking at the effects of total sleep deprivation 1 to 4 days. So these are extreme cases of sleep deprivation. A lot of these studies were actually done by the military, so there would be cadets in training, for example. And there's also chronic sleep restriction studies in which subjects are getting restricted amounts of sleep for a number of days in a row. And surprisingly, you might find, in most of these studies, there's little or no effect on aerobic and anaerobic physical performance. So a whole bevy of different kinds of measures of the ability to perform physical activity. In fact, is not strongly affected by sleep restriction or sleep loss. And that includes the physiological responses to exercise. So the ability to perform exercise and physiological responses to exercise are actually fairly minimally affected by sleep loss. But performance can be affected, and performance is affected by more psychological factors. So time to exhaustion in some studies has shown to be reduced by sleep loss, but more consistently it's perceived exertion. So the subject's subjective experience of the amount of work that they're putting out to maintain a certain level of work output is being affected, is being amplified by sleep deprivation. So it's more of a psychological issue. As far as cognition and mood, these are where the effects are really quite pronounced. And there's been many, many studies on cognition, and greater than 100 studies. And almost all of these will show serious impairments of a whole range of cognitive tasks, manifesting as early as 20 hours of continuous waking. Sorry, did you ever hear that? No. So there's clear negative effects on things like reaction times, sustained attention, decision-making, multitasking, flexible thinking. This is all executive functions, working memory, the ability to hold and manipulate information. In addition to that, there's also very strong effects on mood and emotion. Not as many studies, but fairly consistent results. More labile mood, more increased negative and decreased positive responses to ongoing events, challenges. So the effects of sleep deprivation are primarily in the realm of brain functioning and not in the ability of musculoskeletal system to perform work.
A question about the studies that looked at like reaction time and stuff.
Yeah.
Have there been any studies that have looked at sleep deprivation in athletes and like skill-specific reaction times?
Yeah, there's been a few, but most of this work has not involved elite athletes. Mm-hmm. Relatively little work has been done on elite athletes, even where they've been looking at sport-specific. That is a good question. So much of the literature is involving distinct populations that sometimes it makes it hard to generalize across. That's certainly the case in studies in which they've looked at effects of longer-term sleep deprivation on physical performance. A lot of those are very specific kinds of subject populations, looking at military cadets, for example. In terms of cognition, most of that work has been done on just general population. And even in studies where there's one study, which I've got a slide on, which they were looking at soccer-specific skills. This one study, and they weren't actually professional soccer players. They were amateurs, probably good players, but they weren't professional players. So there's total sleep deprivation, and there's also sleep restriction, which is more relevant to day-to-day lives to most of us. And there's been some really good studies done recently. Van Dongen is not far from here, is at the University of Washington. Balenki was a staff scientist with the U.S. military and is a very good scientist. And they did, both of these groups simultaneously did experiments when they were looking at time in bed, restricted time in bed. So this would be a 4-hour time in bed condition. This is a 6-hour time in bed. This is 8-hour time in bed. And these are consecutive days, so they're limited to that amount of time in bed. I don't know how carefully they were monitoring their ongoing state, whether they were, able to sneak a nap here or there. But you can clearly see that there's, and what we're looking at here, the measure we're looking at here is a psychomotor vigilance test. So it's basically testing reaction time and the ability to maintain attention and to detect the target when it appears on a screen. So these would be little tests that you would do for 5 minutes, at hourly intervals, let's say, or once every few hours over the course of this experiment. And you can see that there's a decreased performance. The number of lapses and the average reaction times are getting worse over time. They're accumulating rapidly at 4-hour time in bed and 6 hours, even at